Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 21 of our main LeetCode challenge, and the problem that has been given to us today is the count square submatrices with all ones problem. Again, if you want to try solving this problem on your own, you can pause this video and check out the LeetCode link given in the description below, and let's get started. So the problem statement is that given a m into n matrix of ones and zeros, you need to return how many square submatrices have all ones. So basically you're trying to formulate or you're trying to understand how many squares can you make, and the condition which it has to satisfy is that the squares should have nothing but ones. So obviously a square with length 1 would just be a simple element. So all elements which have 1 inside of it can be construed as a square of length 1. So you have around 10 squares of side 1. Similarly, you can sort of look at the next values, which is from this index till this index. So it sort of forms a square of side 2, and that's also something that needs to be counted. And similarly over here, the portion which I'm highlighting, and so on and so forth. So in total, you just need to calculate all these guys, and the output over here is 15 because you have 10 squares of side 1, 4 squares of side 2, and 1 square of side 3. So this is a pretty straightforward problem. There are not that many conditions that you need to really take care of. They've given a few hints if you want to go through them, but they're not really necessary. So whenever you find yourself in a problem like this, we've solved a similar problem also like this before, where we were trying to calculate the total number of square or the maximum square that we could formulate. The way we went about it was by using dynamic programming, and the concept was really simple. We can sort of go through the concept again. Um, all it sort of worked around with was that if you have a particular element, you check the topmost element, the element on top of it, the element on the left of it, and the element which is on the diagonal left of it. You basically check for all those values, and if all those values have the same number, well, in essence, what would that dictate is that you've formulated a square. So if you take this element which I've highlighted over here, and you sort of look at what's at the top, what's at the left, and what's at the top left, you can see all of them are ones. And what that sort of tells you is that if all of them are ones, then that's sort of like a square for you. And that's just some condition that you can use. And in dynamic programming, you can actually sort of maintain all those values as you're moving forward. So in essence, if we calculate all those values and all the inside our entire dynamic programming matrix, if we can sort of maintain all the squares that we've got so far, all we would have to do is we would just have to sum them all up, because that's what's happening over here as well. So they're just basically summing it all up. So the only difference would be that if you have one over here, one over here, and one over here, well, this would become 2 in our dynamic programming, or I'm just going to call it the DB matrix. When it sort of becomes 2, it sort of needs to also remember that, hey, there's a 1 over here as well. So if we just add it, we can just say, hey, if it's 2, that means it can actually formulate a square of side 2 and also a square of side 1. So basically 2. So we just need to sum it all up. I hope that logic is pretty clear to you, but I'll try to print out the matrix and then it's going to be a lot more easier for you. So we're going to start with our base condition as usual. We're just going to say, hey, nothing's been given to us. You need to return, we're just going to return 0. The next thing that we do is we initialize our DP matrix. So the DP matrix has to have the same shape as that of the matrix, which has been given to us as a parameter. And I'm just going to make sure that all the values which have been pushed inside of this thing is 0. So that's something that you need to consider. And for this, and I'm just doing this really quickly just so that you guys could probably use the same convention. This is a list comprehension, as you guys know, but it's a pretty straightforward way of just constructing the same thing. I can do a quick print over here just for you guys, just to show you like how it sort of constructs, and this should have the same shape. So you can see it has the same shape, and then sort of we can move forward with everything else. So now what we want to do is we want to just iterate through all the elements inside our matrix, check whether that matrix has a 1 in it, and then we sort of try to identify the condition which we just talked about, top left, top and left. That's what we're going for. So that's pretty straightforward. We just say for I in range of length of matrix, and similarly traverse through all the columns for that particular row. And while we're doing that, all we need to check for is, well, if matrix I comma, well, I comma j is equal to 0, then you don't need to really do anything. That's pretty straightforward. In other cases, you would also want to take care of, because you're going from top left and top left, you want to make sure that you're not going out of bounds. So we'll take care of that as well. So we'll just say, hey, if I is equal to 0 and j is also equal to 0, well, in that case, you want to make sure that you're just updating the values as they are. So you just say dpij is equal to whatever is there in matrix I comma j. It's pretty straightforward. There's not really that much you need to focus on over here. But let's just go ahead with our else condition. So the else condition is, hey, when you don't have to worry about the boundaries or the top boundary or the left boundary, now what you want to do is you just want to calculate your dp. That is where you're going on the top, the left, and the top left. So that's pretty straightforward. You can just say dpij is going to be equal to, well, in this case, you already know that we've satisfied this condition. If this condition is not been satisfied, then it's going to be equal to 1. And we can also update this as 1 just for clarity's sake. So what we can do is we can just say 1 plus whatever is the minimum on our top. What's the minimum between our top, our left, and our top left? So let's just do that. It's pretty straightforward. And again, if you're having difficulties like following this, entire problem statement, that's okay. It's understandable. You can actually find another LeetCode link which I've given in the description below, and you can sort of follow through with that. It should also have the same thing on how you would construct a square matrix. So in essence, what's going to happen now is if I just do a quick dpij, what you're going to see is it's going to be a little difficult to understand what's happening. Oh wait, sorry. dpij is going to return dpi comma j. We just need to return the dp matrix just to understand what's happening. So you can see over here that all for the top row you have the same values, but for this guy, which is the second element in our second row, when you sort of look at that particular, sorry, this guy. So I'm going to call it the third column for our second row. So that's going to be easier for us to understand. So when you look at that, you can see that the value over here is 2. And it's sort of pretty intuitive now. What you have to do, you just have to basically sum up everything that you have. And that should ideally just give us the values that we need. In Python, there are actually multiple ways of sort of doing this. And if you're not aware of that, that's okay. But all you need to do is you just say return, and we're going to be using something called as sum. And inside sum, since you need to sum up everything that's there inside your matrix, you can just do sum of map of sum of whatever the matrix is. So what's going to happen over here, it's going to first pass the row, calculate whatever is the sum of all the rows, then calculate whatever was the sum of all the rows that you had got. So that's basically it. So let's just go ahead and run this, and hopefully this should run fine. And you can see that's running fine. Let's just go ahead and submit this, and hopefully this should be submitted. Awesome, you can see that's been accepted. And this problem is actually pretty straightforward. Again, if you're having some difficulties, I'm going to put in a link to one of my other YouTube videos where I sort of went into depth about how you would sort of go about, constructing the dynamic programming matrix. But it's pretty straightforward, to be honest with you. Cool. So if you did have any comments or there's something that you didn't understand, do leave it in the comment section below, and I'll try to get back to you as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We are a discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.